Hi everyone, and welcome to today's Lunch and Learn event. My name is Erin Nash, and I'm the Partnerships and Community Engagement Lead here at DiUS. Before we get started, I'd like to begin by acknowledging the traditional custodians of the lands we are meeting here today. I pay my respects to elders past, present, and emerging, and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of Australia. I also acknowledge and pay my respects to our Aboriginal and Torres Strait Islander people joining us today. Now, in case you haven't worked with DiUS before, we're an Australian technology consultancy that specialises in using emerging tech to design, develop and deliver cutting-edge solutions. This includes our in-house expertise across digital data and devices and the convergence between all three, which is where the topic of today's Lunch and Learn fits in. Additionally, as this is a panel discussion, we welcome your questions. You can use either the Q&A feature in Google Meets or submit your questions via Slido using the code 1943273. Now, as many of you know, the Internet of Things has become widespread in today's society. It has the ability to improve the way we live and work by bringing everyday objects to life, making them part of an always-on, intelligent network of interconnected devices. Not only does IoT facilitate automation for greater efficiency and productivity, it also generates a huge amount of data from which we can gain insights and make better and more informed decisions. But despite its power and potential, IoT is not without its challenges. For example, security, reliability, and scalability are common challenges faced by organisations with a connected product in market, and it's something that we see regularly here at DiUS. That's why we wanted to host this panel discussion with our clients and consultants who could talk to these challenges, along with sharing a few solutions and success stories along the way. So without further ado, let's get started with today's Lunch and Learn. I'll now ask our panelists to introduce themselves and provide a bit of background into their IoT journeys. But before I do, unfortunately, Barry, who is scheduled to join us, is unable to join us today. However, we'll still be hearing from the wonderful Andrew and Zoran. So to kick off, I'll hand over to you, Andrew.
Thanks, Erin. Hi, I'm Andrew Thomas, Chief Architect of Melbourne-based drone logistics company Swoop Aero. We design, prototype, manufacture and deploy into service the only end-to-end infrastructure for drone logistics on the planet. We've currently been approved to fly in over 14 countries around the world and reach over 4 million people with our integrated drone logistics networks. At Swoop, we are very well known for delivering medical transport networks across Africa, but integrated drone logistics is more than just about delivering a product from A to B. It's about delivering an object from one three-dimensional point in space to another and getting it there where it can deliver value. From our perspective, the difference between us delivering a vaccine for a child in Africa or getting a camera above a flood zone in regional Australia are fulfilling the same purpose. Integrated drone logistics is society's new infrastructure. Getting through the vast distances, traffic congestion, location inaccessibility, inhospitable terrain, and data shortages. With our new and growing networks, we're on track to achieving our goal since our company's founding of delivering to 100 million people in 2025 and 1 billion people in 2030. In regards to our use of IoT, unlike drones that you see, I suppose, that use point-to-point based communications, I suppose in the consumer market, we treat our aircraft as IoT devices connecting up to AWS. Interfacing with our aircraft as both from a flight perspective and as a digital twin, managing both its software and hardware perspective from its end-to-end life. Alongside of aircraft, we also have a number of IoT devices that support the end-to-end logistics operations, from the chargers in the field to the end devices of cold chain management. I will hand to you, Zoran.
Thanks, Andrew, and thanks, Erin. Hey, folks. My name is Zoran Angelovski. I'm one of the principal consultants here at DiUS. And I guess I'm one of the fortunate consultants here at DiUS. I get to work with organisations such as Swoop and Sealy and a lot of others as well, in particular in the IoT space. So my background for a long time was telecommunications. I'm an electrical engineer. And these days I head up the team here at DiUS that really leads a lot of the development activities at the device end. So this is building the physical devices, the firmware inside those devices, and also how they connect to the cloud infrastructure. So that's my background. Thanks, Erin.
Wonderful. Thanks, everyone. So I might start with our first question. In light of recent high-profile security breaches in Australia, What emphasis have you placed on IoT security, and what's the first step an organisation in a similar position should take? Let's start with Andrew.
Cool, thanks, Erin. So being in the aviation industry, safety is the core of what we do. And I suppose this particular topic of security is one of the key points that highlight us to come and work with DiUS on how we had the end-to-end IoT infrastructure and made sure security was like top of our priority. In terms of, I suppose, security, it's like that broad principle of what does that actually mean. I suppose if I divide it up into the two components, and a good way to think about it when managing security is I suppose preventing unauthorized modifications. So that was, I suppose, pretty critical to us with aircraft in the field. This applied to both the ability to prevent it with people that have physical access to our aircraft or any IoT device we have, but as well as over there, update security was paramount. Another part of that security picture is IP protection. So, we've got aircraft operating around the world with various people using our services. So we wanted to be able to protect our physical code as well as code such as computer vision models that we've deployed, ensure that that is IP protected, end-to-end security. So I suppose my biggest tips around security are thinking about where does security matter to you? So there's those different principles. Are you trying to protect IP? Are you trying to stop people making modifications sort of things? And how does that play a role? And I suppose the big highlight of security for myself is in our work with DiUS, we had to place a lot of trust on security. It certainly wasn't a field prior to working with DiUS that I had a whole lot of understanding of the ins and outs of all the microscopics of security. And we started a project and signed an actual original project with DiUS that, to be honest, I didn't quite understand, but I was like, okay, I know DiUS understand the high level goals of what we're trying to achieve and the encryption and certification. And that was the key priority for us in engaging DiUS. Probably hands nicely over.
Yeah, fantastic. Thanks, Andrew. So Zoran, what's the first step you would recommend an organisation should take?
Well, I guess really beyond fear and nervousness that you sort of, initially get. I mean, in light of the recent sort of breaches that we've seen, I guess the first step really is, what work have you done previously? How have you prepared for such a scenario? So I think the first step reflects on, I think, really security is there to be worked on from ground up, from when you first start a project. And it's not just the technical, but it's also the organisation aspect of it. So I think if there is a breach, and context is always a wonderful thing, but what does the process tell you to do? So what steps do you need to actually go through to ensure that the impact is minimised? So having that preparation, having it built into your product, whatever it is that you're building from day one. And I guess the recent breaches have really been around, the sensitivity of data and people accessing those sorts of things. But if we bring it back to a physical device, what does it actually mean for the physical device itself? Do you have the ability there, for example, to recover from a particular disaster? Can you roll back to a firmware that operates on these devices prior to when a vulnerability was introduced? So it's really being prepared and having the ability to cope with being hacked or a breach occurring. And it's with the mindset of this may occur at the very beginning of a project. And the other part I would add, I think Andrew spoke to some really good points there. There's the sensitivity of the data, there's protecting the intellectual property. But then I would also say, even if the data doesn't have value, what does it mean for the brand, for your business, if there were a data breach? Even though the value of the data may not be so high and the damage by obtaining that data isn't so high, there's a reputational damage that needs to be considered as well. So they're kind of the very high level things that I would be looking at.
Fantastic. Thanks, Zoran. Great tips. Now, in terms of scalability, connected devices provide the opportunity to do things a little differently and can open up new avenues of exploration. What steps do you need to bear in mind when scaling with IoT, especially when expanding into new markets around the world? And so given your focus at Swoop Aero, Andrew, I'd be keen to hear your thoughts on this.
Thanks. So I suppose, the approach of our aircraft as IoT devices was quite different to the market. Most people, set up drones and communicate directly to them. One of the things that's allowed is we've got now the setup that we have remote operations centers in various parts of the world, that one pilot is able to pilot up to 30 drones at once. So they're able to connect up to the AWS platform and control those aircraft as IoT devices. So it's really allowed the scale of operations. We've obviously, you know, in the IoT world of managing communications around the world is one of those particular challenges. How do you manage SIM cards and the different plans in different countries side of things? And the satellite communications in areas like the DRC Congo, where cellular isn't as prevalent. In terms of, I suppose, some of the capabilities that treating it as IoT provides is over their updates. It's pretty much in an IoT world become a pretty much critical part, and certainly for us, it's a huge value. Being able to have a global fleet of like thousands of aircraft that we can simply update on a process of once a month and go, let's roll out new reliability, safety improvements or features for customers to that fleet is an essential part, and the value that we get of them being IoT. One of those challenges we had to deal with in that and had to think about is how do you roll out that update? So you know, updates of various sizes in terms of that need to download off different networks. So managing not just the day-to-day of network usage of the device, but if you need to, how big is your update? And if you're going to push that update once a month, what are the communications that device has to do that update? So there's some of the challenges we had to work through to get that out in the field.
Wonderful. Thanks for sharing those with us, Andrew. And so based on your experience in helping clients scale with IoT, what steps can you suggest people take when expanding into new markets, Zoran?
Thanks, Erin. I guess context is really everything again. It really does depend on the product. But, you know, when we bring it back to a physical device, something that's connected, I think Andrew touched on a lot of key points there. What are your remote capabilities? What do they look like? What can you actually do from your operations center? And, you know, do you need a truck roll, or how do you avoid a truck roll? That's sort of the fundamental question. And I guess a part of it also involves, you know, when you're looking to scale it, you know, it's one thing to deploy in the field 10 devices, and it's another thing to deploy thousands, if not hundreds of thousands. So what does that user journey look like for that device to be deployed? And then when it is actually then complicated if you're going into different regions. So depending on how your device communicates, what sort of communication protocols it does support, you may have it sorted for one region, but what does it mean for other regions? So there may be a level of customization you need to go through. It may be something that you provision, but then you need to get into the nuts and bolts. For example, are you shipping devices out of the factory? What does it mean as soon as they land in country? You know, different countries communicate over Wi-Fi. They operate over different channels. Does it mean that you need to pre-configure some of these devices before they land in country because they may actually not turn on or not be able to communicate, I should say, at the other end? So there's a lot of thinking through the steps, the process. What is it that you need to ensure that that device will actually connect, will actually communicate, and what are the different profiles you need to understand for those different regions as well? The other thing I would consider, I guess, is, and this is based on a few examples that we've seen in the past, communication standards are always changing. So we had a client a few years ago, this is going back a few years, they had deployed a product on a cellular network where that cellular network, and this is an extreme example, that cellular network was to be retired in a year. So essentially they had a lot of stranded assets a year after actually physically deploying these devices. So keeping an eye out on the future, keeping an eye out on the difference of the telecommunication standards, what's going to occur, what's happening in your own local environment, but also what's happening in those overseas markets, and being flexible for those markets. And of course, that's just the operational aspect of it. And I think Andrew could probably attest to it. The other things that may impact is, what does it mean, for example, as Swoop Aero, what does it mean if you have to go through some approval process for the local aviators in those other countries? And that can be a very long lead time task and quite an onerous task as well. So kind of very high level, some of the things that I'd be considering.
Wonderful. Thanks, Zoran. Really interesting case study and some great tips there again. Thank you. Now I have one more question to ask, but if there is anything that you would like to ask our panel today, you can submit your questions using either the QA feature in Google Meets or via Slido using the code 1943273. And thank you for your questions so far. Now, Andrew, what was the trigger for you to look beyond internal capability and engage a partner that could help with IoT security and scalability?
Okay, cool. So we're at this point that, we had aircraft operating. We didn't have, I suppose, over-the-air update capabilities and, the number of aircraft. We wanted to do updates and manage that fleet, plugging into it, pushing out updates sort of thing. And we knew that that just wasn't scalable, particularly as we had everything operating around the world and the different time zones we had to manage. Security also being at the forefront, both in preventing change and protecting our IP was pivotal to us, and we wanted to solve that problem. So we did, I suppose, look and work through how would we solve this ourselves, and had some experience, and you do the various research of what IoT frameworks and off-the-shelf products are out there for over-the-air updates. But a lot of those products that we found for us were layers that were built on top of the OS. So they had a certain amount of flexibility that they touched, but particularly when it came down to having that 100% control of the OS end to end, and really that confidence in the security of when it comes down to the full encryption and the ability to change, they just weren't at the standard that we wanted to meet. And I suppose we internally didn't have the skills to do that end-to-end execution. I suppose, touching on what we actually got out and kind of working through with DiUS to actually get an end-to-end solution is we came out with a cutting-edge approach. So we've got a fully signed read-only OS that we can confidently boot and be very confident that no changes have been made to that OS in terms of modifications in the field, that has come out of our build server such that we know that code, and we can release updates every month, but we know that those updates are coming from us, and we are preventing anybody accessing that through full encryption on board the actual aircraft. So, though we certainly did hit off what our key priorities and maintain that ability to over-the-air update our aircraft to maintain fleets of thousands of aircraft operating 24/7 around the world. So that was, I suppose, one of the key components there.
Fantastic. Thanks, Andrew. So the first question that we've received via Slido is one for you. So how do you avoid someone else taking over the aircraft with a different signal?
We don't do, I suppose, point-to-point communication. So most drones you see out there, they operate on 900 megahertz, which is connecting straight up to the drone. We use, I suppose, both encrypted channels, so AES 256, if you kind of get down the technical standards, and we also manage our end-to-end comms very specifically. The other side of things is we take the approach of very layered security. So even myself with complete access to our pilot system, I can only actually execute a certain number of commands because the drone itself will only execute commands predefined to that route that are actually allowed. We don't actually allow that remote control to send our aircraft anywhere. So really treating that and going, okay, if someone broke down this or someone malicious was at this point, how do we protect against that?
Fantastic. Thanks, Andrew. I actually have a question for our IoT practice lead, who is not part of the panel, but I'm going to throw to Frank Lucino. Frank, I'm keen to hear your thoughts on the current chip shortages and supply chain disruptions and what the alternatives are.
Cheers, Aaron, and hi, everyone. We've been seeing a fair bit of an impact with the chip shortages and even our own DiUS product as well as customer products. So we're looking at different ways for customers to sort of reimagine how they could actually provide services to their customers, as well as looking at the long term, what is available, what are the lead times. And what we've sort of seen is the lead times are actually published aren't really that factual. They're probably more of an indication, but still looking at how organizations can plan for what's coming, either in the next 12, 24 months, and really utilize what they currently have. What we have seen is a utilization in the data they're collecting and looking at other ways to provide insights to their customers with what they have out there in the field already. So really looking at how data can play a significant part of ensuring that they're providing additional value to their customers. So from the shortage perspective, it's industry-wide. It's really planning ahead and trying to look at alternatives, you need to, and there's a bit of a process to go through that piece of work, but it's also looking at what is currently there and what other ways can you provide value to your customers, even from a data perspective. Thanks, Aaron.
Thanks, Frank. We've got another one that's come in for you, Andrew. So I understand that Swoop Aero utilises machine learning. How does this provide additional value, and is having models at the edge something you're looking at?
Cool. So firstly, models at the edge is key to our side of things. Is we operate in environments of the world such as DRC Congo, where we are flying on SATCOM. So the ability to put high volume of traffic back through our comms channel is not always something that we have. We have a number of different uses for, I suppose, computer vision and machine learning. So we have it from a safety perspective, that the aircraft's landing camera on landing looks down and goes, do I see a person under me? And will I stop that landing process and return home? So that is happening on board the aircraft with computer vision trained there. We also use it for our end-to-end use cases. So I've talked about logistics, but we also do have the capability for coastal monitoring. So in a very cost-effective manner, we're able to monitor like a large section of coastline, for example. So our 30-to-1 pilot setup, combined with computer vision on the board the aircraft, allows the ability to provide a fleet of aircraft to monitor an aircraft, with emergency responders not having to watch those feeds live, but able to get alerted if something is seen and bring it to their attention. So if computer vision flags, I've seen a shark in the water, an alert can trigger for emergency responders to both open that live feed if the data communication is available, and look and go, yes, that is a shark, and we will respond, or a swimmer in distress, those types of things. So really efficiently being able to operate at scale is, I suppose, the key part of computer vision for us.
Fantastic. Thanks, Andrew. And this next question is probably a combination from Andrew and Zoran. So the question is, do you design and build each node IoT device individually and replicate, or do you need to consider how they behave as a group?
It's a really good question. I think, sorry, I guess I'm going to drop you into this one, Andrew, but I think it's a fantastic question, because we've had some experience with the work that the Swoop guys are doing specifically for this example. Did you want to take the lead there, Andrew? I think both is the short answer. So certainly, and again, I think there's a lot that you can do with individual devices in terms of how they behave, and and what you need to, how you need to interact with them and so forth. But there's also a lot of information that you can get from the collective as well, and how you might improve that product. Andrew, did you want to add to that?
Yeah, so I suppose, see if I've understood the question correctly, but in terms of, I suppose, design, we design, I suppose, across the fleet of aircraft, that each aircraft behaves and acts in the same manner. So because we have to go through aviation certification and really prove to regulators, we need to have that foundation of hours that go, okay, we've got many thousands of hours that are proven across all our aircraft to actually get their authorization to fly beyond line of sight of the pilot and above people in various areas. So that commonality across the fleet. In terms of, I suppose, the data side, so we collect a huge amount of data from every flight. So pretty much about a gigabyte per flight of data that we collect. And we look at that aggregate of data from all those IoT devices to look at what is the normal. So for example, you look at something basic like a vibration sensor. If you're looking at the vibration, and you can look at tens of thousands of flight hours and go, across all our different aircraft, what is the standard level of vibration that I should expect in my right-hand wing, right? Because it's never going to sit dead still, but you want to be able to identify as something abnormal. So looking at that, we're able to look at the aggregate, and then this comes down to those over-there updates, is when we can push a trigger that goes to the onboard health monitoring system to say, hey, I'm in the middle of flight, and I've sensed that my right-hand wing, I don't know exactly why, but it's slightly vibrating more than normal. And the aircraft can then automatically turn around and fly home to ensure safety of that end-to-end platform. So that's, I suppose, that balance of how we take the aggregate data from IoT and feed it down to a single aircraft.
Thanks, Andrew. Is there anything you wanted to add to that, Zoran?
No, look, I think that covers it. I mean, it's very much definitely both areas have a role, the individual and what that device is is doing, and then what does it mean in the aggregate? Is there a deviation from the aggregate? Is there something that's an outlier, or is there something that you can learn?
Thank you for that, Zoran. And this next question relates to what Frank was just talking about around chip shortages. So do you produce your own flight controller, or is it coming from a third party, and how is it going to, and how are you going to handle chip shortages? Andrew, this is probably one for you.
Yeah, thanks. So yeah, certainly end to end, we've got like our electronic gurus are always at it, making the new circuit boards and new designs. The chip shortages definitely has been a big challenge, and ordering things as early in advance. I know pretty much you're putting together your procurement, you've done your design, and until you can't like really confirm that design until you've ordered that many thousands of that chip, because often we do those designs and you're having to create those modifications. We do, I suppose, end-to-end chip design. So from even down to some of the raw components of the ESCs, which is the actual raw motor controller, and the BMS, the battery management systems, even all those raw systems, we've actually end-to-end designed ourselves, because that gives us that end-to-end control when we have a very large scale of aircraft. So we wanted to be able to collect a significant amount of data that I suppose a lot of those off-the-shelf systems didn't allow us to do. So yeah, certainly electronics and all that hardware, it's very much scaled and built in-house.
I could probably add a few things there, Aaron, if we have the time for it. So I guess, I mean, we've been living through this in our own products as well. I guess the disruptions have been there for, I guess, obviously over 2 years now. And in the worst case, you're looking at potentially a redesign. But I think the steps you'd take is act as early as possible. So if you're supplying a physical product, look at that product and try and act and place your orders to secure the parts as early as possible. However, there are a few things you can do to prepare. So if you haven't gone through, I mean, the components that make up a hardware design, they'll sort of fit into different categories. There'll be the very common things that it's easy to get alternatives. Then there'll be sort of that middle ground where there are alternatives, but you may need to make some changes, and being prepared for that is a good thing. And you may want to do that now, if you like. And then there's the really hard parts, the problem parts, where you're reliant on a particular processor and your firmware is built around that processor. And we're going through that with our own product, where we've actually been forced to design a particular part out because some industries have actually just completely absorbed the supply of that processor. Now, I guess a difficulty like that could be turned into a positive. When we looked at it, when we reviewed it, we had always had the plan of going down the path of a cost reduction. So we took that opportunity to change the hardware design, change the firmware, not necessarily as a first step to achieve that cost reduction, but to take us on that path. So we took a negative and we tried to turn it around as a positive. But again, it's about, and we're doing this now with some of our clients as well, it's about going and analysing what are the easy parts you can swap out, what's the middle ground that you try and find alternatives for, or as many as you can, and then what are those really difficult ones and how do you deal with those? So it's about breaking that problem up.
Fantastic. Thank you both. These questions are coming in thick and fast, which is brilliant. So the next one, can you elaborate on the AWS IoT services you're using? Greengrass, MQTT, streaming, S3 uploads, etc. Are their services complete?
So I'll assume that one's coming to me.
You, Andrew.
So a whole good mix of AWS services. So talking from aircraft side of things, so IoT core, so all the aircraft act as a thing within AWS, and that end-to-end MQTT based communications is used for command and control, as well as triggering over-the-air update process. So then those over-the-air update processes, you need to have that stored somewhere. So S3 for storage is extremely key. So we have a huge volume of flight data logs all coming up to S3 from every single flight, and that enables the process of analysis. We have for video streams, we use Kinesis video streams to push up that feed and the low latency. So we're able to have each aircraft where comms are available, push a live video stream up to Kinesis Video, and you can have many subscribers connect to that. In terms of, I suppose, authentication, we went down the path of Cognito for user authentication because it's very tightly integrated. So we've built a serverless-based platform, so Lambda at the core, and API gateway and the various functions there, integrated very smoothly with Cognito to authenticate users up to that platform. In terms of, I suppose, completeness of the services, that's, I suppose, one of those decisions that we kind of do make. I often find, we'll look at one particular service and say, okay, how does this one particular service in Amazon compare to all the others that are, masters of the video domain, for example? Now, I've taken the approach with Swoop of, having too much breadth of having to interact with all the different environments. It's much easier to go, hey, if Amazon have that service, unless I can kind of really pull a hole in it, we will go with that approach. It just simplifies our infrastructure in terms of how systems and services interface. So the security of how one system can talk to another, staying within that Amazon world has certainly been a huge advantage in our ability to move quickly. Hopefully that's answered that one.
We actually have a follow-up question to that one. So can you please provide a brief outline of the processor platform, OS, code size, etc.?
On board our aircraft, we are quite based on NVIDIA. So on the NVIDIA's Jetson series. So that gives us the ability to both manage all the comms with the pilot, but also is the interface of our sensor suite. So the computer vision side of things, the Jetson has the GPU and is able to do that processing. In terms of how that interfaces up to the cloud, we use both a mix of cellular. So we actually use even 2G because we're over through DRC Congo and Malawi all the way up to 5G from a cellular perspective, and actually switch over to Iridium Certus satellite communications in areas that we don't have comms. So that's, I suppose, the comms layer and how that interfaces. And then that connects up using AWS IoT Core. And then Lambda, we've gone down the path of particularly Node.js and React-based core from the development side sitting in the cloud.
Great, thanks so much, Andrew. The next question is for both Andrew and Zoran, actually. So do the drones process the images on board, or is it sent to the server? And if it's sent, then how do you deal with latency and connectivity?
I think that's, I'll jump in to start with. So always dealing with that onboard side of things. So if I talk about the safety and trying to do the automated landing and the computer vision, if we, we've got 30 aircraft in the air, if they're, and a mix of satellite and various levels of cellular communication, we couldn't rely on, pushing those images up and having to deal with latency. So having the computer vision models run at the edge on board allows us to have that confidence that even if latency is there or no comms are actually available, or no high bandwidth comms, I should say, are available, then the same action and process can be taken.
Excellent.
Hopefully
Thanks, Andrew.
that
Zoran, do you have anything else to add to that one? Otherwise, I'll ask you the next question.
I think it was largely covered. So I guess it really depends on your application. And if your product can actually, if you do have a good cloud connection, sure, you may decide to do it in the cloud. But if you have something that's closer to real time, that needs to interact in real time, then I guess you need to make attempts to do it locally and have the grunt to do it locally as well. So, yeah.
Yeah, fantastic. Actually, this one's for you, Zoran. So how do you manage the risk of pushing over-the-air updates to devices?
It's a good question. I guess Andrew touched on it a little bit earlier. I mean, the first point, I guess, is really ensuring that your software is locked down. So, it is encrypted and it's signed, and so you know that it's authenticated. But the other thing is really it comes down to the device and how you've engineered the device. So to do it securely, to do it in a reliable manner, your device, I mean, typically an embedded device is a resource limited device. So you have finite amount of energy, you have a battery, you have a potential if it's battery powered, you have a finite amount of processing power, memory, and so forth. So you need to have the capacity in the device, and your image needs to be of the right size so you can support what we refer to as dual image support. So there's an A/B image that gets loaded into the device, and only once the new image is actually downloaded, it's gone through its self-checks, you've actually ticked that it is operational, that you switch over to the new image. So really, it's fundamentally, it comes down to ensuring that you can support dual image in the device itself.
Great, thanks, Zoran. And this one's for Andrew. The drones require a landing patch. How do you prevent the drones from landing on fake landing patches?
So I suppose you're also sending them to those coordinates. So a fake landing patch, I suppose some of the process of why we have landing patches, the ability to go to a location and accurately land between buildings, and I suppose provide that accuracy to landing. The second part of it is, particularly in for example, Africa, you might not have direct comms with the people on the ground. So we have a communication flow there where someone can put the time, meaning, hey, I'm ready to receive that aircraft. In terms of, I suppose, preventing landing on fake patches, it's, I suppose, not really an issue because the patches have to already be predefined within the exact area that we're flying. So we're not going to be flying to an area that has another patch. Sorry, that's a beautiful dog in the DS office.
There is a guard dog puppy running around the DS office right now. Another one for you, Andrew, and more about Swoop Aero, and you touched on this briefly in your introduction. 1 billion parcels delivered by 2030. Is this only with medications, or is Swoop considering moving other items of other origins too?
So I touched on earlier. I suppose we take the principle of logistics is about not just moving a parcel or a thing, but that could be a camera. So particularly like emergency services, and being able to use our logistics aircraft to instead perform a search and rescue operation or fire operation. So in that same way, moving other types of equipment, providing that. But end to end, our, I suppose, ethos is drones for good. So delivering critical supplies is the core of what we're about. Doesn't necessarily mean staying within that medical frame, but essential supplies. So the concept of delivering coffees and side of things is not a core part of our business and what we're after. We're about delivering drones for good.
Fantastic, thanks, Andrew. I guess a little bit further to that, do you, in terms of are you planning to carry more than just medication, and how are you going to achieve your growth goals?
So end to end, it's about creating logistics networks. So we're looking at, for example, we're expanding a Queensland network and our existing Malawi network, which is now countrywide. Our ability to deliver end-to-end products across that. So that can fit at the moment. It's the two-way service of medical goods is the priority there. In Malawi, we already do, I suppose, the flood monitoring side of things is that critical service, and the ability to any other, I suppose, critical and vital suppliers able to deliver those. Once we have a network in place, that is the growth of expanding that network and going, how can that be used to deliver other valuable services? So that could be, for example, we look at an agricultural space. You've got someone with a broken down agricultural machinery at a remote area. We're able to, and yes, our aircraft are lightweight, but for example, if that machine is broken down, it could be just a basic filter or something that's required. We're able to deliver that essential service and get those equipment back up and running. So looking at how that can act within the field.
Great, thanks, Andrew. So if anyone would like to submit a question, please do so via Slido or through the Google chat. But before we wrap up, if no more questions come in, I'd be keen on your final thoughts, Zoran and Andrew, on the importance of IoT security and privacy.
Sure. Look, I guess I think we touched on a lot of things earlier on. It's really around building it in from day one. Context is everything in terms of your product. I guess the sensitivity of the data, Is it fairly innocuous data or is it highly sensitive? You need to consider the things that we spoke to earlier. If there were a breach, what's the reputational damage? Even if the data is not so sensitive, I guess, what does it mean for your own intellectual property if someone were to be able to do it? Having the plan in place, assume that you will get hacked. And again, in terms of the building it from day one, have an approach in terms of the product that you've got, the sensitivity of the data, how much data you need to keep, whether you need to separate data. If you're dealing with business customers, for example, do you separate that data so that if one business customer is impacted, it doesn't impact other business customers? The other sorts of things that we have seen in the past, quite often, these are very simple things, but I think it was an example a few years back where a temperature sensor in an organisation was actually attached to the same internal network as a lot of the imported infrastructure in the organisation, some of the finance and so forth. So outsiders actually hacked in through a very simple temperature sensor, where they actually then got into sensitive areas of that organisation. So have a think about how that separation might occur. Not too different to when you're at home, you've got a guest Wi-Fi network versus your own Wi-Fi network. So some simple steps like that, but all of that is built in from day one. And I guess if you're looking at then bringing it back to the context of the physical device, and it becomes really even more so important that if you're looking at ground up security, it needs to be built in at the hardware layer. So if you haven't done that and your service is such that it demands that, you're potentially then spinning hardware and making changes. So it really is get onto it early, get the right sort of advice on it, and build it in from day one. Thanks.
Fantastic.
Zoran.
Thanks, Zoran. Yourself, Andrew, do you have any additional thoughts?
In terms of, I suppose, the security and pushing out those updates. The key there is how do we have that confidence of what we're pushing out is reliable, and that's, I suppose, where we have gone down that approach of the aircraft, well, any IoT device, I should say, validating that it's from a signed source before actually performing that boot. So that's the signing certificates that we have from our end-to-end build environment. I think I'm trying to remember the exact question on that one.
No. Thank you. That's all good, Andrew. We've actually just had another question come through. So can you outline how Swoop and DiUS work together and who did what?
Did you? Yeah, sorry.
Yeah. So I suppose we had the end-to-end infrastructure for IoT and our command and control setup built. That's the core of what we created and interfacing up to the AWS cloud. What we really worked with tightly on DiUS is that fine-grained embedded resources. So I spoke earlier about using the NVIDIA Jetson, and that we really wanted that end-to-end IoT security that would connect back up to our AWS environment. So we worked very tightly with DiUS on that process of creating a full read-only OS that could be switched over there and performing those updates with a high level of confidence between those modules. So yeah, did you want to elaborate on that one?
Sure. I guess we were involved in the really, I guess, two sides at a very high level. I think Andrew mentioned it from a security side of things. What does it mean at the various layers within the device from a security point of view, at least in the device team? The other part of it was really around productionizing. So I think it's one thing to have sort of software that you go at in a limited capacity, but then when you're looking to go out and productionize it so that you can actually scale and achieve all those wonderful things, you need to take a very, very different approach. We sort of came in and said, okay, as we were talking earlier, we've got this resource constrained device. What does it mean for the device if we're going to go out, scale it, build it? What does it mean to update that device? And really make it manageable in the future. So we built the underlying infrastructure so then Swoop could go in and take that and deploy it at scale in a secure way.
Fantastic. Thanks, Zoran. So that looks like all of the questions. But before we wrap up, I would like to share with you our IoT lens. So as you heard today, security, reliability, and scalability are all common problems faced by organisations with a connected product in market. So to help organisations address these challenges, DiUS can assess the current state, evaluate IoT workloads, and deliver a comprehensive analysis with a list of actionable recommendations to help prioritise remediation, effort, and budget. This is supported by a business case, strategic roadmap, and implementation timeline that outlines the best course of action according to the organisation's business objectives. Additionally, organisations who undertake DiUS's IoT lens will receive a $5,000 in AWS credits upon remediation of eligible workloads. So if you're interested in learning more about DiUS's IoT lens, you can scan the QR code currently on the screen. And additionally, if you have any questions about anything that you've heard today, please feel free to get in touch with us. So finally, I'd like to thank our panelists, Andrew and Zoran, and of course, Frank, who stepped in. And thank you for sharing your insights with us. And to all of you, thank you for joining us today.
Thanks, guys. Thank you.
Thank you.